Hey guys, just wanted to do a video today of the wheel where I'm at, since we started going digital kind of stuff. Right now we are only running one cycle. We are collecting half cycle on the rest period. We are running through 700 feet of aluminum wire. We're only running the center coils on all the coils, so only one out of the three on each set is being used. Like I said, there's no physical load on the axle today yet. We're only collecting a half cycle. I just wanted to show the RPMs, 50, 60 RPMs at the moment. Not real fast at all. It does go faster with adjustments and other things. But so right now the input voltage is 21.1 volts. We're drawing under a quarter amp. So 5-6 watts running right now. So I'm gonna quickly stop it, go to the back of the motor. I'm gonna hook the physical load up so we can see the difference in the RPMs from unloaded, and then the consumption rate, what difference it is, and then I'll show what the physical load actually is, because apparently there's a few people out there that just think that this is a standard pulse motor. It has no torque, no balls. Well, we have 3 layers of magnets on it right now, so we're running 240 magnets. So basically right now we're pulsing 40 hertz into the motor. If we was collecting the return cycles, it would be at about 80 hertz with the current RPMs. But anyways, we'll get more into stuff like that later. So let me go ahead and shut the trigger off, stop the motor, quickly hook the load up, and then we'll let it start up from almost a complete dead stop and let it power through the load on its own. Just to show that even with a half cycle pulse motor at the right size, there's plenty of torque there. It's all about RPMs on driving your loads. Okay, folks. Just to show that we modified everything a little bit. We've now got the steel banding around to hold all the magnets in place. There's 3 layers. We redid the alignment. So current amp draw is going to be roughly a half amp. So we have the physical load connected to the back. We are using an automotive belt pulley system. So if you don't want to see a spinny spin, you might as well just jet on out now. It'll probably take 2 or 3 minutes at least to get the RPMs up close to where they were. When our amp draw gets down to about 0.33, is we're going to use about 100 milliamps more with the load, which ain't bad. I've been mostly trying to adjust my coil length for my startup amps. So I'm going to do my length of wire so that the amps are decent on just dead startup, and then wherever they end up at the end is where they end up. I'll keep adjusting things when I change my voltages because I'm not exactly sure what I want to run at yet. I definitely want to get up to the 113 to 120 volt consumption or potential for the input of the motor, because there's a huge difference between, say, 5 volt 5 watt and 120 volt 5 watt. There's a huge difference in how the motor performs, and it's just got a lot more punch to it. So we're still around 21 volts. Current amp draw is 0.36, 37, 38. We'll let her come up to speed some more yet. And I really hope this proves to some people that there's torque here. It ain't that it doesn't have torque, it doesn't have the RPMs yet. I mean, we could sling this thing up to super fast speeds if you really want to dump heavy amperage into it. We're just going to let it come up on its own. There ain't no need to sling it up. So our coil gap between the 3 sets of magnets and the coil is roughly 1.25 inches. So we have 1.25 inch distance between all the coils and the magnetic ring. And the weight of the 240 magnets and the steel and the screws that we put into it on the outer ring added 30 pounds of flywheel weight on the outer ring of the rotor. So there's a lots and lots of kinetic energy being stored into the flywheel now as it speeds up. It's not only driving through the load to get the load up to speed, it's also storing all that energy into this very large mass. So amp draw is 0.32. We'll let the RPMs come up a little bit more, and then we'll go back and show the physical load. We'll check it again when we're done checking the physical load. So I'm going to pull you guys off the tripod. We'll show the distance between the coils. There's quite a bit of distance there. I mean, I can literally put my hand in there. She's still coming up to speed. So we'll go ahead and come around here to the back. I'll show the physical load. I have to get the flashlight on because it's kind of dark back here. So our physical load is the squirrel box again. It does blow plenty of air at these RPMs.